Hey, welcome back. Good to see you again. Hope you're all well. Now that I caught the big virus, kind of homebound here, so it's a good time to start getting caught up on some of the repairs that I got backlogged here. And this is a Pioneer PL-8 turntable. This one came as a group of 3 items. One of my clients purchased a Pioneer receiver, cassette deck, and turntable, and had them dropped off at my house. And this is how I got it. This is exactly how I got it. I haven't touched it yet, haven't looked at it. We'll discover this together, how it is. But he wants me to go over it and make sure everything's 100%, so it's no problem, I can do that. And it looks like it's got a nasty crack in the lid. Somebody put some weight on there. So let's unwrap this and see what we're up against here. So let's see here. What is holding this? I have to turn this around and see what's holding this. It's just stuck. Okay. So the previous owner of this is local to me, so that's why they had it dropped off at my place. Just it's convenient for him. So it's pretty dirty, but it is a nice looking unit. Let's see here. Got our mat. Needs a good cleaning. Groove isolator by Oracle. This is not the original mat. Okay. Now he did tell me that he bolted down the platter. So let's just take these screws out just for transport. Looks like they're M5 bolts. Oop, it's not turning. What's going on here? Oh, we got some, okay, some packing blocks, that's why. Alright, we're all good now. Put those away. So it's pretty nice features. It's got a power button here, speed selector with 2 lights, a quartz lock. This is a direct drive, fully automatic direct drive, quartz lock light. We have a selection of 2 different sizes. Feels like a mechanical switch, a repeat button with lights, and this is the play stop button. It has a cartridge on here. It's called XL ES28. I don't know if that's good or bad or what. It looks aftermarket. Doesn't look original. Stylus looks like it's there and it's intact, so everything's good. Got a 45 puck, and everything looks complete. The platter itself, it's not very heavy, but do the business. Okay. So it needs a good cleaning. Let's try this out with some power. Yeah, that mat is not the correct one. It sits quite a bit higher than it's awfully thick. It's about 4 millimeters thick. I don't think that's the correct one. There's no strobe for speed control. There's no adjustment for speed control. So we'll have to check all this. So let's get an album and we'll put it on here and see what it does. Alright, so it's all queued up. I got Dino Latino, Dean Martin. This is, by the way, this is 1962, so it's 60 years old. Interesting. But anyways, that's what we're going to hear. A little bit of it. I can't really get copyright strikes, so let's take the lid off as well. And put this aside. Needs a good cleaning. Let's see here. Not too bad. Okay, let's turn this thing on. Unlock it. Power's lit up. Set for 33. 12-inch. Repeat is off. Hit play. And we get nothing. Absolutely nothing. The light does come on. Oh, here we go. Why did it take so? Maybe the switch is dirty. Let's try this again. Now it's going to start working. It's supposed to be fully automatic. Okay, we only got one channel. Seems to be working. Let's see how it... See how the auto return works. And it doesn't. Okay, so it's going to need some adjustments. Let's hit the stop button. It should stop. Okay. It does not want to stop. Does not want to auto return at all. There we go. So yeah, it needs adjusting. So for the most part it's working. We got no rate channel. And I think we have just dirty switches and controls here. And it needs an adjustment. So we can go through and do all that. Clean it up. Alright, I'm in. And I have to say this has to be one of the worst turntable designs I've ever seen. Thumbs down to Pioneer for building this piece of whatever you want to call it. To get it apart, you have to remove the 4 feet, the 4 rubber feet, and you have to pay attention because there's 3 that are the same and there's 1 different one, so you have to pay attention to that. And then you have to disconnect the wiring harnesses, and you have to disconnect the phono out line from the top, otherwise it won't separate. And then there's some other trickery that's going on here. And then you have to remove the counterweight and its port from the back of the tone arm. You have to remove the head shell. And yeah, it's just a terrible, terrible design. They could have thought of something better than this. But anyways, we're in. I'll stop complaining about that now. What am I seeing? I'm seeing not too much. Not too much going on here. This post here has some kind of a decrepit rubber on it that is petrified and crumbling, so I'm gonna have to deal with that. But I got the motor out, and let's have a look at it. It's got a little electronic circuit. It has a quartz oscillator, and it has the circuitry for that, for the speed. Let's see here. This is direct drive motor. We can service the bearing if I can get this thing apart. Now, bearing itself seems fine. It seems to spin okay. There's really no issue with it,
but we're going to take it apart and re-lubricate it anyways while we're at it. We got it apart, so might as well do it. Okay, so this cover here, well, we got a shaft inside there. So there's part of the bearing. We need to remove this E-clip. Okay. This should remove. And there's our motor. Keep this part clean, don't let stuff attach to it. Otherwise, you'll have problems when it turns. Now, I guess there's really no need for us to remove that unless you need to inspect the coils or repair anything under here. It's got our 4 field coils, and then outside there is a sense, the speeds rotation sensor, and then you got 2 Hall effect sensors. Everything looks good here. Okay, so there is really no need for that to come apart unless you had an issue with it. So let's put this back together. Put this big E-clip back on. Okay. Just like every other turntable I've taken apart, they have very minimal lubrication on it. It's almost like the bearings are dry. Like you're not really wiping anything off here. And let's use some solvent. Yeah, there's really not much here at all. Oh, great. Lost my Q-tip end in here. Not having a good day. Okay, let's dry it out. Okay, it's clean. Let's use good old 3-in-1 for the bearing. And I'm just going to put 1 drop on the end and let it dribble down. And that's more than enough. Assemble this. And you know when you do that you're getting air compression, and it's a very close tolerance on these bearings. Okay, torque these 3 down. And that should be it. Okay. Not much else to do here. We have 2 pots for speed adjustments, VR1, VR2. There's no power supply on here. The power supply is on the lid, on the deck. But this feels pretty good, so I'm going to reinstall it. Perfect. All right. Now, want to look at this switch here. This switch is what is this? This switch here, I think, controls the motor, because these wires go directly up to the, oh, these go right up to the power supply, and this is what switches the motor on and off. And I have a feeling this switch is bad, because when I first tested it, there was no action from it. So let's check the contact resistance on this switch. And I'll just put my, okay, so we're in resistance mode. And right now it's open, so I don't know what it's measuring. It could be measuring just anything. Let's activate this switch. Okay, here we go. I'm gonna open or close the switch contacts. Then we get 30, jumping around between 30 and 36 ohms, which is unacceptable. Open it, close it. 27, but it's just a random, yeah, it's roughly around 30 ohms. That is unacceptable. It should be around 100 milliohms. So this is going to cause a problem in your operation of your turntable. So just clicking it on and off here so you can see that it's repeatable and it doesn't get better with use. So let's take that switch out and clean it. Okay. The switch just snaps in place, so we can just pop it out of its position. Just go easy on the old plastics here. They don't want to have that grease on my thing here. What is this? I don't know. Something gooey on my screwdrivers. Okay, let's pop this up and out. Now if you want, oh, this one's riveted. Okay, so maybe we should just replace it. Yeah, let's just replace this switch. See if I can find one. Okay, got another switch. Let's test this one. These are normally closed switches, so let me show you what it looks like on the tester. There's open, and here's closed. 12 milliohms, 11 milliohms, 13, 14. No more of this 30 ohm crap. 16. Actually, it's a little high. I might have to spray a little bit of. Let me see here. Let's work the switch a bit. Yeah, we're down around 9, 10, 14. What I want to see is consistent and repeatable measurements, not 11 one time and 14 the next. Okay, there's 11, 11, 11, 13. This one I could pop open. No, I think I'll just leave it. It's working a lot better than the other switch. Here, let's go back to the other switch. I'll show you again what the other switch, the original switch, was doing. And we're at 62, 92 ohms, 90, 80. Open, closed. Up in the 50 ohm. This switch is gone. And that reminds me, I'm going to need to order some new switches. All right. So this will just drop right back in. This is physically the same size, the same everything. The only difference between these two switches is, that I can see, is this one has more spring force than this one. This one's very light. This one's a lot heavier. But I don't think it's going to make a hill of beans difference here. So I'm just going to pop this one in. Okay, so this is turntable is going to challenge me to no ends here. I tried replacing this switch, and it's no simple task. You just don't plop a new switch in and expect it to work, because it didn't. It didn't work at all. In fact, there is a little mechanism here that presses on the switch plunger, and there's actually a spring mechanism in here that limits the amount of push on that. So yeah, this is very weak spring in this one. This one's quite strong. Let me demonstrate the difference between the two. Let me show you here. I'll get a scale. So here's the original switch that came with the turntable, and I'll just press down on it till it clicks. I think you can see that. Probably get about 25 grams of pressure. Okay. Here's the replacement switch that I have, and push down on it. We're almost at 200 grams. Well, we are over at 200 grams. So that's why it wouldn't work, right? So I went through all my stash of switches, and they all have a heavy actuation force, quite strong, and they won't work. And even I went on the my parts source there and looked at some data sheets of new switches, and even them, they are around 150 grams of pressure to activate. So this is kind of an unusual beast, this one. We're going to have to repair this switch to get it to work, because I don't have a replacement, and I can't really order one unless I don't know. I suppose if I search through different databases in parts places and find one. Don't even know if one's available. So this one's riveted. It's got a couple of aluminum rivets. Let me show you. 2 aluminum rivets. Just got to drill these aluminum rivets out. There's the other side of it. And we should disassemble and clean the switch, which should be no problem. Now, what do we do? Once we drill out these rivets, I'll have to figure out a way to hold the switch back together. I suppose we wouldn't need to, because if I put the switch in the holder, it has 2 clips, one on each side, and it'll hold the switch together. So we could actually just drill these rivets out, throw them away, take the switch apart, clean the contacts, put it all back together, and drop it in here, and it should hold together indefinitely until somebody takes it out, and the switch should work like new again. Okay, so I'll do that. All right, let's go through a switch clean here. See what we can get for this. Something about this size I think might be okay. Should be all right. Yeah, it's aluminum. It's very soft. Just want to pop the rivet out. Come on. Okay, I think we're good. If I have a tool to push this out. Okay. Yeah, it wants to come apart already. Sometimes they snap together, sometimes they use rivets. Okay. So let's position this so you can see. So our contacts are down here. It's really difficult to see. It's normally closed contacts are the ones that I want, the ones with the two wires connected. So it's this set of contacts here on top. Now there's a number of different ways I could do this. I could disassemble all these pieces and take them out. I think I just might do that. Let's try. These pieces are just set in place into the body of the switch. There we go. And let's do the other one. Let's actually remove, let's see here, where are we? Tweezers. Take out the spring. Take out the plunger. Now we should be able to take out the center contact. I think it's all one piece. Yes, it is. Okay, let's take this one out. Just don't want to damage anything. This copper is a beryllium copper spring contact, and that's very fragile. And there's actually another piece here. You don't want to lose that. So if we can separate, let's see here, let's separate these two and take this little piece out before I lose it. If it goes spring and it goes across the room, then we are out of a working switch. So let's take this out. Take this out. Now I have to remember this comes from the back side. Actually, it goes on the side with the brass. Okay, so I'll have to remember that. Let's have a look at these contacts. Okay, so here's a look at the contact under the microscope. And you can see it is a brass carrier. It has like a copper slug on the back that's pressed in. And it is actually a silver alloy on the contact tip. See how black it is? And that's what's giving us our contact resistance. So let's look at the other part. Here is the center contact, and you can see it's got the same thing. It's got a lot of oxidation. Let's turn it over. Here's the other side. It's like a little silver slug. It is a silver alloy. I don't know what the composition is, but it's mostly silver. It's probably 90% silver or 75% silver. It might have palladium in there. It might have who knows what other metals they use. Sometimes they gold plate these little slugs, and they don't oxidize like this, and that's fine. But when you get a switches that are required to carry higher currents, you can't gold plate them, because the gold will just flash off with the arc and destroy the plating, because they put it on so thin. So look how black that is. Let's try and clean that up with some deoxit. I'm going to use deoxit D100, and I'm going to put some on a Q-tip, a little drop on a Q-tip, and we're just going to scrub the end of this thing and see if we can get it better. Here comes the. So let's just scrub this thing. It'd be hard to do on the camera, so I'm using my left hand to scrub with. I'm not very coordinated. It doesn't seem to want to respond to the deoxit. Now, let's see what we're picking up off the Q-tip. The Q-tip is picking off some black stuff here. You can see it's kind of dirty. Let's try the other piece. Let me try this side. Let's try scrubbing this. Yeah, it's getting better. I'm picking up we might need to use some abrasion. I typically don't like using abrasion on contacts because it removes material. And when you start removing material, in some cases, if these contacts have enough material, you can remove some of it. Yeah, I don't know. The Q-tip's coming out pretty dirty, you see, and this is showing a little better. And let's try this one some more. This one here is really bad. This is the one that is the normally closed contact. Yeah, I'm going to get some sandpaper on this and clean this up better. It's coming off in patches. Okay, so I got my sandpaper stick here, and I'm going to use 1,000 on this one. Let's see if we can do this on camera. Probably won't be able to see anything. I'm just going to hit it with 1,000 grit. See if we can clean this up. Try it like this maybe. I don't think these are gold plated. Let me check this. Maybe it is gold plated. You know what? It probably is. And I'm removing the gold plating right now. But gold doesn't oxidize, so yeah. I've never seen gold plated contacts oxidize like that, so it can't be gold plated. It's got to be some kind of an alloy. Let's just go through and clean this up a bit. 1,000 grit. I think that's good for that. Let's try this one. Now this is going to be a little more tricky. I'm going to put my finger on it and get it to contact the paper. Let's see here. A little better. I wonder. Oh, this is really difficult to see what I'm doing here. Yeah, that's better. Okay, let's flip the other side. I can't remember which side made the contact with the normally closed. I think it could have been this side. If that is gold plating, just take off the absolute minimum just to clean it up. We'll follow it up with the D5 or the D100 again. Okay, that looks good. What about this side? Looks good. Okay, now this one. Looks good. Okay, let's reassemble this switch. Okay, we're back on the bench. Let's put this back together. So, how did this go again? I believe this went in here. Okay, is it working? Yes. Oops. Maybe it wasn't latched in. Okay, let's try that again. I think it only goes in one way. Maybe I bent this? I don't think so. Okay. Do you call this thing a toggle spring? Don't want it flying across the room. Okay, I think I got it. Now there's two tangs pointing up here, and I believe that goes up towards the spring. So I'm going to put this in next. That's not right. Line up the contacts. I didn't clean the contacts on that one. That's the normally open. And I'm not interested in normally open right now. Because they don't affect the circuit in any way. So let's put our spring back in. Can't imagine constructing these on the assembly line. You know, it must be some mechanical way of doing it. Get the spring in the right position. It has to be. There we go. Okay, let's get the plunger in place. The plunger goes here. There we go. Okay, now we need our last contact. Should probably put this one in first. You gotta make room for it. There we go. If everything's assembled correctly, it should click and work. Make sure these are bottomed out. Okay, let's do it. Put the lid on. Let's do a test on the contact resistance. Okay, so there we are. We're open. Let me close the switch. Oh, look at that, 8 milliohms. Open, closed, 7.9. It's very nice, very nice. That's absolutely perfect. Remember we were getting 35, maybe even 50 ohms before. Now we're getting 7 milliohms, 7, 8 milliohms. And it's repeatable, it's accurate, it's coming back again and again. So those contacts are nice and clean. And this switch will not give us any more troubles. Not for a long time, maybe another 20, 30 years. Okay, let's put this back in. So I expect the reason why the engineers at Pioneer selected such a switch with such a low spring pressure is just so it didn't have any influence over the tone arm in its operation. Let me see if I can get this cleaned up here. I need to clean this up. Should have done this before. There we go. Got it out. Okay. So this should just snap right in and hold itself together. There we go. This one's some better solder. Clean up these messy joints. There we go. Okay, that's back. Now, did I mention that I checked the ESR on all these capacitors and they're all good? So I left them alone. I didn't touch anything on the electronics on the motor board. Couldn't see anything wrong. I touched up a few solder joints here and there, ones that looked a little weak. I'm still going to get some alcohol and clean off the flux on this, and then we're pretty much done here except for lubrication. I don't see much going on for lubrication. Everything's free flowing here. Not much is happening. Alright, one thing I got to take care of here is we had no rate channel on our output, so we're going to do some continuity tests on the cabling. Put this to continuity, and let's check some of these wires out here. This is the ground. Okay, that's good. Ground's disconnected right now, doesn't matter though. Okay, the ground for the right channel. That one's good. Center conductor for the right channel. That one's good. Left channel. Outer conductor. Good. Center conductor. Everything's working. And we have, let's check for shorts. No short. Oh, we have a short here on the right channel. That's not good. What is going on with that? Now, is that in the cable itself or what? Might have to figure this out here. So we know we got a short on the right channel in the wiring. That's why we got no right channel. So it could be in the tone arm, it could be in the cable. So we'll have to investigate that a little deeper. Alright, let's hunt down the reason behind no right channel. We got a short on the right channel connector here. So what I did is I removed the 3 screws that holds the tone arm assembly down to the base, and I can just lift it off and flip it over and have a look. And I don't see anything. So what I'm going to do is I got my iron warmed up. This red wire here, sorry, I'm trying to got tickles in my throat. Let's zoom in here so you can see what we're doing. Okay. We got different colored wires here. The white wire is left. The blue wire is left ground. The red wire is right. The green wire is right ground. And then we have on the chassis ground we have a black and a yellow wire. So those two, okay. So let's check for let me get this out again. Let's make sure we don't have any shorts between chassis ground. I didn't think we did. I don't remember if I checked it or not. We just got one between ground just got one between right ground and right signal. There's our short. Chassis ground. Nothing there. Okay. So I'm just going to lift this red wire and see if our short goes away. Okay. And then we'll see what side is the short is on. We still have it. Yes, we do. So it's in the cable. And it's not in the tone arm, which is good. So we need to figure out how this cable is shorted and where. I'm just wondering, sometimes these don't look original. I don't think these are original. Maybe somebody put these on. So let's pull this apart and have a look inside. I might have to lop these ends off and put new ones on. This one here does not look. If I can pull the outer cable sheath off, or the connector. Okay, there we go. And yeah, somebody did this. There, let me show you. And you can see this. There is a strand here that goes from ground and it's going down to the center conductor. So we just need to fix this up. This needs to be fixed up and soldered properly. This isn't even soldered, it's just crimped on. And it's an aftermarket. It's got the screw terminal, which is fine. It's gonna work. It's just it needs to be dressed up better than this. This is we got a dead short here. Okay, so let me fix this up. Okay, so I just soldered the braid to the shell and made a good connection there, and tinned the center conductor, wrapped it around better, and got rid of all the frayed wires and put it back together. There's no more short, so we can close this one up. I wonder, okay, let's just push this back together. We should check this one too while I'm in here. Let's pull it apart. And this one is a little better. It still needs to be soldered up. I don't know if you can see this. Let's do that right now. Put that like that. We'll just we'll ground the we'll solder the ground connection to the shell, just that there's no chance it can go weak or high resistance. Here we go. Get it to flow. And I think the center conductor is okay, but I'm still gonna do what I'm still gonna do is I'm still gonna tin this wire because it's all fraying. Okay, just wrap this around. These RCA connectors are not my favorite ones to play around with. Okay. Wrap this around, bring it down. Good. Let's check. Make sure we have no shorts. Okay. It's good. It's good. Alright, should have our right channel back. Let's move on to the switches on the top. Okay, I'm checking the main power switch here. And this brown switch. And as far as I can see, it's wired in series with the power transformer and the power line. So it's on the primary side. Yes, it's on the primary side. But I'm having something really weird happen here. I'll show you. Okay, that's the switch open, and I'm getting 1K resistance. I close the switch, I get 21 milliohms, which is good. It's fine. There's nothing wrong with that switch. But why, when I open it, I get 1K? It shouldn't happen like that. And it's not plugged in, obviously, otherwise I'd blow up my meter. The power cord, let me connect this up to the power cord and see what I get. So I'm going to connect my meter directly to the plug on the power cord, and I got 1K resistance. When I close the switch, I got 460 ohms. So the only thing across that switch is this 100 nanofarad safety cap. Let me check with my probes and see what it measures. Maybe that cap is no good. Okay, here we go. There we go, 1K. So what is going on with this capacitor? I might have to replace that safety cap. Okay, so I pull the safety cap out, check it with my ohm meter, and it tests good. And I pull out another safety cap, check it with my other bridge meter, and it shows 1.8K. If I go here and test it with my multimeter, it's probably going to show open again. So there's something about my meter, my LCR bridge, that triggers a reading on one of these caps. I guess maybe in the resistance mode, maybe it's feeding it a frequency that's feeding through or something. I don't know. So I put this cap back in and go with it. It's still good. Alright, so also I was looking at this regulator transistor here. This is a 2SD837 Q1. It's got all three legs are cracked, so we're going to resolder this one while we're here. I don't know if that was causing any problems with operation, but they were pretty cracked. They were cracked to the point where yes, they would have. So I'm just going to clean this up and make sure that they're good, and then I'll clean the board and then we'll reassemble. You can check these caps as well. I don't think you'll find anything wrong with them. We've got 2 caps, 3 caps. Let's check them while I'm here. This is a 470 at 50 volts, 0.05, it's good. This one here reads 1.5. This one here. All the caps are fine. I don't expect to find any bad caps on these things. So, clean that board as well. Next, I have to clean these 4 switches. Now, I think it'd be easier if I just remove them. I think I can spray deoxit in and work them, and we'll go with that. But I want to make sure I check them after, make sure that they're not high resistance. Alright, so I'm just about prepared to marry the top back on to the base. I'm pretty much finished with all of my work that I've done in here. The switch cleaning, everything else. There's 2 other things we need to pay attention to when we close this up. There is a lever here and this black lever here that will match up with this and this. Now, this lever here has a post on it, and it's a brass post, and it's got like a rubber, well, it was rubber, it's all petrified now, but it's all black and pretty much disintegrated. It's just crumbling to black carbon. So I'm going to pick all this off because it is disintegrated, and I'm just going to build it back up again with heat shrink tubing. I don't think I have any hose that's small enough. I think heat shrink tubing will work, probably about 3 layers, just enough to build up the thickness again to the original, and we can get rid of this disintegrated rubber. So let me see what I can do here. This stuff here is just, it's just crumbling. Let's clean this all off. And I suppose if we don't have it on there, it's not going to mate properly with the other piece. So yeah, it's just totally crumbling. Let's clean this off. It's all stuck on. Okay, get some heat. Another layer. Let's do this quick before it. There we go. And next size up. So that's 3 layers there, and it's pretty much the right diameter. Just going to shrink this up really good. I don't know if I need another one. Maybe I'll put one more on. Maybe the last one. Perfect, I think. Yeah, that's good. Okay. Let's trim this off. Clean up this. Okay. Perfect. I don't think that's going to come off. No, that's good. Okay, now to put these two back together, there's 2 slots, one on the bottom, one on the top, that you can get in there with a pair of tweezers, and you can manipulate the arm to the position you need, and then you can drop the cover in place. So this one down below here, I need to, let's see here. Oh, I had it. Okay, that one's in place. There's an arm and then there's a spring, and you want to get that piece in between. Now we need to figure out how to do the top one, and I don't know if I can see this one from above, or I have to do it from the side here. It would probably be best if I had something I can rest that on. There we go. Now if I could get this up a little bit position, something longer. Actually, you know what? I'm going to use the slot they provide. And you just have to position it and then drop it in place and hope for the best. Not the easiest thing to do. Okay, I think I'm good. Except this one jumped out again. There we go. That one's in. I think the other one's in too. I'll check it again. Alright, let's have a look at the stylus here and the cartridge itself. Now, I gave it a little blast of compressed air from a can just to clean the dust. It was pretty dusty. And just having a look here at the stylus. I can't really get a good look at the stylus. It's pretty small. But the cantilever's straight and everything's good that way. It's not bent. Let's have a little side view here. If I can get this to focus. You see the stylus is definitely there, and I can't tell if it's conical or what. It doesn't look damaged. I'm going to take a little swab of alcohol here and give it a clean. It looks kind of dirty. So let's do that right now. I just want to make sure that the diamond's not chipped or cracked or broken in any way. So I keep cleaning it. Let me see if I can get a focus on this. Very fragile. That aluminum tube is very thin, and it's supposed to be thin, so it has a very low mass. So that's why they make them so out of such thin tubes. Okay, now let's see if I can get a good look at this. I'll try rotating it. Where are we here? Okay. Can't really see. Hang on here. Let me get close in. The lighting on this thing is... Maybe I can... Better lighting. Try turning the lighting up. Oh, there we go. If I'm not mistaken, that looks like an elliptical stylus. I don't think it's conical. Well, maybe it is conical. If I look straight on, yeah, it's a conical one. But it looks okay. I don't see any chips or breaks, so we're going to leave that. The branding on that cartridge, Excel ES28. Never heard of it in Excel. Alright, so we had a good look at the stylus. Seems okay. Protrudes quite a bit. Quite a bit of distance there. Anyways, one thing I'm going to do is I'm going to replace these screws. These look like definitely the wrong screws. They're 19 millimeters long, and they don't need to be that long. Plus, another thing is I really question if this thing's ever been set up properly. It looks like they just mounted the cartridge straight on the head shell, I don't know if it's going to track right. I'm not going to bother checking it. I'm just going to take these screws out and replace them with some shorter ones I got here. So let's do this now. Reason I'm doing this, you probably, maybe some of you know this, but on your head shell you want to keep your mass down to a minimum. Any little extra weight is going to have a negative effect on its operation. So let's put some shorter screws in, and these look like they're perfect. Plus they're black, and got a black head shell, so let's put black screws on. Okay, screwdriver. Okay, we'll adjust all this after. Okay. Now if I leave this a little bit loose, you should be able to slide around. Okay. Alrighty. Let's put this back on the tone arm. And I'll put the lock screw in, and then we'll just do the setup. Okay, so I forgot to mention, if you do take these turntables apart, you're going to need instructions on how to put it back together. There is a process, because there is two things that need to interlock with each other so that the turntable works properly. There's this drive lever here, and there's a slider here. This slider is for the 7-inch, 12-inch setting on the turntable, and this one here is your repeat setting. These two buttons and this. So yeah, there's a whole process, and if you don't get it right, it won't work. So you have to go through and do these procedures to get this turntable back together, and it's quite involved. I was telling you, I just pulled my hair out a little bit earlier because it's not the easiest thing. So we're going to set up the toner, or the stylus, the cartridge, and we're going to use this. This is a gift from one of my viewers, Mike. Thank you very much, Mike. I'm going to actually have a chance to use this today. So we're going to use this as a gauge to set up the cartridge. And what we're going to do here is we are going to, obviously the power's off, we're going to line up the stylus on the bullseye. Now you might have to turn down your anti-skating, because if I turn anti-skating back up again, I'll show you what happens. If I put it down, it just wants to zip off the end. So I have to turn the anti-skating down to 0, and it'll actually sit there. So I put the stylus right on the bullseye, and then from above I look down, and if I see the cartridge is a little bit crooked, what I do, I got a camera in my way and I can't really do this because my head is not okay. So what I'm going to have to do is I'm going to have to turn this cartridge a little bit, because it's a little bit cockeyed. So let me see if I can turn this and maybe tighten this down a bit. It probably won't tighten. Okay, let's try this again. I'm having a hard time seeing this. just going to turn it a little bit. I think I'm pretty good right there. Let me have a good look at it. Yeah, I think we're okay. Now, second step is you move it into this bullseye. Oh, that anti-skating wants to go again. Turn down to 0. But what we do here is I notice that the stylus is a little bit off. So what you want to do here is you move your cartridge in and out, in or out, depending on how it's situated. Now this one looks like it has to go out, so I'm going to actually loosen these screws and pull this cartridge way out. Probably to about here. I think that's might help us out. Let's go back and check our alignment again. That is not bad. Okay, and then here. Yeah, that looks a lot better. What you want is you want it straight on both bullseyes. That one looks bad. That one looks okay. That one looks not bad either. Alright, so I think I've got it there. What I'm going to do is, without the camera, I'm going to go through the process one more time, make sure it's all 100%, because I can't get my head over top to look directly down to see if it's straight or not. So I'll shut the camera off and I'll go through the process once again. I'm pretty sure I got it close. Very close. Okay, let's set up the tone arm tracking force. And to do that, I'm going to use a scale. We're just going to set it up with a scale first. There's a couple ways you can do it, with scale, without a scale. Actually, let's do it first without a scale. Let's put the album on. The problem I have here is this mat is not OEM. This is not the factory mat. This is a aftermarket thing. It says Groove Isolator by Oracle. And this mat actually it's a very dense foam rubber, I think. And it's measuring at about 4 millimeters thick, but it's causing the album to sit a lot higher than it should be. I don't think the original stock mat would be so thick. And then once you put an album on here, well, then you're going to add another 2 more millimeters, right? So what you could do with no scale is you just drop the tone arm on the middle of the album. And what we're going to do is we're going to back off on the counterweight. Not back off, we're going to crank the counterweight in until the tone arm starts to float. I'm going the wrong way. I can back it out. Yeah, sorry, my mistake. Back the counterweight off until the tone arm starts to float. And you'll hit a point where it's still got a little bit of weight there. Just go a little bit more. Oops, and then it takes off. So I got too far. Let's go down a bit. Okay. Just pull this up a little so you can see what I'm doing. I'm turning the back part here, the silver counterweight, and I'm just trying to get it. See there, it's floating. Okay, right about there. It's floating about 3 millimeters off the album. It's a little too high. Let's bring it down a little bit. Right there. Oh, still floating. Okay. It's just touching now. Okay, now that we have our stylus just touching the album at 0 grams, what we do is we'll protect the stylus, and then we'll turn the gauge to 0. Right, set to 0, and then we'll rotate the entire thing, the entire assembly back in until we hit 2 grams, and then we should have 2 grams. Okay, that should be 2 grams. So let's test that with our scale and see what we get. But this won't measure 2 grams, I'll guarantee you. Here we go. Oh, look, it makes a liar out of me. The point I was trying to make is the scale adds a thickness to the platter, and that throws the weight off. So let's take the album off. Let's take the mat off. Let's put the scale back on. The thickness of this scale should equal the mat plus the album, roughly, within a millimeter. So let's try this again. Oh, we're still at 2 grams. Okay, we're good. So that's it. It's set up. Now, lock this down so we don't damage. Next thing we got to do is turn your anti-skating from 0 to 2 for 2 grams, and we're done. Alright, last thing we need to do is our speed check. This has no quartz lock window where we can watch the speed, the strobe itself. Let's see, we have to add a strobe disc, which I did, and we're set to 45, I believe, and that's on the inside. Oh my god, what the hell's going on with this thing? No quartz lock there. Okay, I had a little upset there. I had put everything together and I was ready to do some final tests and speed tests. And when I started it up, the motor wouldn't turn. And I was thinking to myself, what the hell did I screw up now? Like, because typically when you're the one working on it, you're the cause, right? So I went through and I spent about a day checking everything I could think of on the motor. I had troubleshooting here. Oops, sorry. Troubleshooting flow chart, and going through this here. This is actually pretty confusing too. I don't know what a play stop terminal is. So I was pretty much at a stop here when I was troubleshooting, and it says, is the play stop terminal less than half a volt? Oh, I don't even know what a play stop terminal is. So that didn't go very well. But then I read at the top here, and it has this note. It says that the IC, the Pioneer PA 2008, used in the PXM-85 motor, does not have a dedicated ground pin for its internal circuitry, but uses the thermal fan ground. When replacing the IC, make sure that the securing screws retain the ground line between the IC thermal dissipator and between the thermal dissipator and motor base, and motor base to circuit board is tightly secured. Now, I'll show you what they're talking about here. Okay, I had another problem here with the turntable, and to be honest, I thought it was something that I did when I was in here. I was working on the motor, and when I put it all back together, assembled it, I had no motor function. And I was like racking my head off, what did I do wrong this time? And I took the motor out, checked everything over, couldn't figure it out, everything looked fine. But I also noticed that when the motor was not working properly, it was, if I flexed the PCB board a little bit in one direction or another, it would come back to life for a moment. And I thought, okay, great. And I got a cracked solder joint somewhere, or a cracked PCB board, or something to that effect. So I scoured over this board with a fine-tooth comb, resoldered a lot of stuff. Couldn't figure out what was going on. Couldn't figure out what was wrong. And I was going through the troubleshooting procedures for the motor, They have in the service manual, they have a pretty good service manual, even though it's a little bit confusing at times. And I read this paragraph they had up top here, and this is on the troubleshooting page for the motor when the motor doesn't turn. It says the IC PA-2008 used in the PXM85, this is the PXM85, does not have a dedicated ground pin for the internal circuitry, but uses the thermal fan ground. When replacing the IC, make sure that the securing screws retaining the ground line between the IC and thermal dissipator, and between the thermal dissipator and motor base, and the base to the circuit board is securely tightened. So what they're doing here is this motor driver chip, this PA-2008, has is it 6 pins on this side, 8 pins on that side, for a total of 14 pins. And then they have the 2 wings coming out the side. What they're telling us is this motor chip doesn't have a dedicated ground pin, but it relies on a ground connection between those 2 heat sinks. Now, I thought that was kind of weird. So what I did is I went through and I tightened all these screws down, and they were tight. None of them were loose. And but this one here, I tightened down, then it started working again. So it's a pretty poor design to rely on your ground for your chip to go through 1 connection, 2 connections, 3 connections to the printed circuit board. It's not very good at all. What I'm thinking of doing is I'll run a ground wire from the chip itself to the board, and that'll eliminate any break in the ground connection. So what I've done here is actually I soldered this screw down to the board. This is the only screw on this back plate that grounds itself. These other screws, they're isolated, and there's one that is grounded. So what I did is I scraped off a little bit of the screw and I soldered it down. That eliminates this problem, but it doesn't eliminate this problem or this problem. So I think what I'm going to do is I'm going to run a wire from one of these. These screws are long enough I could just put a spade crimp thing on there, and I'll get a proper ground on this board, and that'll be problem eliminated, hopefully, for anybody in the future. But if you have a motor problem and you're racking your brains trying to figure it out, take a good look at these ground connections. One of them might be loose. So, alright, so here's my solution for the grounding problem on this board. Added a nut and spade. I don't know if you call that a spade or what is that, but it's a crimp connector, so that's grounding directly to the chip, and then run a line, drilled a hole, and grounded it directly to the PCB board, rather than relying on this ground screw and this ground screw and these ground screws. I'm just running a line directly to the ground, and that should eliminate all future problems with this motor in that regard. I don't know why they did that. That was a pretty poor design, to have a chip that has no dedicated ground pin and then grounding it like that through those 3 different pieces there. So we do have motor function, so I got power. Let's turn this thing on. Yeah, let's shut off the lights here because my LEDs will flood this out. Okay, so we're set for 33 RPM. Let's start it. And we can see our 33 RPM. I don't know if you can see it very well on the camera, but it's pretty rock steady. So let's try out 45. Let's shut off. Try it again. Okay, 45 is good. We have a quartz lock. Keep shutting down. Let's try this again. Quartz lock's coming on when the turntable gets up to speed. Let's turn it to 33. I'm getting a quartz lock here. Okay, everything's good. Okay, so 2 final tests I need to do is the automatic start. Does the stylus drop in the correct position? And the automatic stop, does the stylus pick up at the correct position? Now, before it was just playing to the end and staying there and it wasn't stopping. So I have this set up. Let's try auto start. Nope, it is way off. Okay, we're going to have to do something about that. Let's adjust it. Adjustment is back here on this little hole. Just going to give it a quarter turn clockwise. And we'll try it again. It's a little early. I could turn it a little bit more. Okay, let me try a little bit more of a turn on that. It seems to drop it a little too early on the album. I can see it. Where is it? Okay. Okay, let's try it one more time. That's much better. Drops right in the lead in. Okay. Okay, now for the lead out. To see how this, does it pick up or not? Yeah, it's not picking up. Okay, I'll have to adjust that as well. Okay, to adjust the Stylus pickup point on the, I have to remove the mat and the platter. And there's an adjustment hole here. So the adjustment screws here through this hole. Turn it, if I can see it, like it's on a floating arm. It's very stiff. Okay. It's a pretty crappy way of adjusting. Okay, I'm finished with this one. This was a tough one. Not very pleased with this turntable. It is a nice turntable. It's direct drive. It's got a lot of nice features. It's fully automatic. But it's difficult to work on for the sense that you have to remove the top half from the bottom half to get in to gain any access. And it's kind of an involved procedure, just separating the two and putting them back together again and getting everything to work right. The motor issue really threw me for a loop. I spent a lot of hours working on that to realize it was just a poor ground connection. I also worked a lot of hours on the automatic return. It wouldn't pick up at the right spot, and making the adjustment wasn't working, and I had to take everything apart and re-grease things, and now it seems to be working fine like it's supposed to. But I want to see the backside of this and never see it again. This, you know, it was a tough job to fix this turntable. So yeah, I'm pleased I'm finished, and this one's going to go back to the owner. I don't think he's even seen it yet. It's actually came directly to my place to get worked on, and then he'll pick it up when it's done. So yeah, thanks again for tuning in and joining. And hopefully you learned something. I know I learned something on this thing, and this was a tough one. So actually it wasn't really designed for servicing, but anyways, take care. I'll see you on the next one.